Good morning everyone, Dr. Nat here. So we are doing orthographic reading today. So these are the topics that we will cover, which is the definition, what is orthographic reading, and how can we do it. There's two approaches that we're going to cover, which is the analysis by solids, analysis by surfaces, missing view problems, we're going to do a little bit of that, and also self-practice problems. These are all very important for your exam coming next week. Alright. So, reading a drawing is the process of recognizing the shape of an object by interpreting the orthographic views. So, you are given the orthographic drawing and you want to interpret what that drawing means. Okay, you know that your drawing is standardized and you want to translate it into a 3D object, right? So, let's say you have this object, it's a 3D object, and if you were to draw it orthographically, you would get something like this for the front view. But let's say you only have the orthographic drawing, which we have seen a lot in our AutoCAD classes. How do we convert this drawing to a 3D object, right? So this is what orthographic reading means. So there are several viewing directions. You may either be given front view with right side view and top view. So that sometimes you're given the front view, right side view, and bottom view. Sometimes you are given left side view, bottom view, and front view. So the ones that are highlighted is the views. And sometimes you're given the front view, left side view, and top view. These are all correct. So it's just the viewing direction, right? And depending on which views give you the most information that you need. So the first approach is analysis by solids. Let's take a look. Okay, so objects are decomposed into solid geometric primitives. So these are some of the familiar solid objects that we know, which is the rectangular prism or just rectangular block, and cylinder, and sometimes we have the negative cylinder, which is just a hole. So these are the blocks that we know and we are familiar with. Other types that we are familiar with is cone, pyramid. Doesn't really look like a pyramid, but we'll consider this a pyramid, and also sphere, right? Sphere. So the first thing to do is orient yourself with the views given, like I mentioned to you before: front, bottom, or right, front, bottom, or left, and so on and so forth. Read the individual surfaces that appear in each view and relate it to each other, and then create a proper solid geometric primitive from each reading and assembly all the solid geometric primitives. So let's see how we can do that. So example number 1, or example A. Remember this sign or this icon means that you're viewing this in the third angle. So this would be your front view. Okay, given the front view, the top view, and the right side view. So these are the views that are given, and we want to construct our 3D object. So here we can already identify that from the front view, we have a rectangular block or rectangular prism that they call it here. From just over here, we already know it's a rectangular block. Okay. And if we're looking at this side over here, the front view, we can see that it is a hole, and this one is also a hole because of the hidden lines. Second example. Now you have, okay, so this is the views that we have. It's different from the previous one. Now we have something that is extruding, or like you have like an external rectangular block on top of the rectangular prism. So first we identify that we have this rectangular prism or rectangular block, right? So this is what we have. So we don't have a hole because we don't have any hidden lines. We still have that circle, but there's no hidden lines, which means that it does not go inside the rectangular prism, so there is no hole. So we have identified that this thing is actually a cylinder. Right, cylinder. on top of our rectangular prism. So example number 3 or C. So given these are the three views that you have, your front, top and right side. So look at it. Can you identify what is the basic geometry that dominates this 3D object? It looks as if it's a rectangular prism, but we also have this side over here, right? So I would say that this is a rectangular prism, and this is like a half cone, sorry, a half circle. So let's see. So the composition, they're looking at this side over here first. So this is our cylinder, and it has a hole because of the hidden lines, and this hole does not extend all the way, it only extends up to this part. So it's not exactly a hole from the top to the bottom. There's like a blockage down there, right? Okay. L shape with a round end. So I identified the rectangular prism, and I knew that we had something that was a half circle down here, just from the views. Okay, is it done yet? So this hidden line tells us that there is something down there, and it satisfies that. So we have two circles because we have a hole, and we have another circle over here. Another circle, and this circle it has a hidden line, so we know that there should be a hole over here, and indeed there is a hole. Ta-da! Okay, moving on to the next example. Example D. So again, given the third angle view, you have three views over here, the front, the top and the right side. Just by looking at it, can you guess what it is? So we have something that looks very similar here. Not very similar, it is actually similar. Oops, sorry. So here we have this rectangular block from the front and the top. But if we look at the right side view, we can see that it is actually a rectangular block. Okay. And from the right side view, we can see that this is an L-shaped block, which is what we're seeing from the front view. We just see this side and this side. And if we're looking from the top, we see this side and this side. So it does look the same. This is what it looks like for your 3D object. Okay, so we talked about analysis by solids. Now, how do we do it? Analysis by surface. So let's see. So first, orient yourself with the views given, the same case like before. Read the individual set of lines or surface that appear in each view and relate to each other. So what I did previously was identify what was the building block of the drawing, but at the same time I also used the lines to help me, right? For this analysis, you specifically use the set of lines and also the surface. You don't imagine it as blocks. So it doesn't really matter as long as you know what you're doing. So an understanding in orthographic projection is meaning of lines and surfaces are almost important. I would say it's very important. Number 3, mentally create and sketch a form of the surface that produce the same orthographic views as those at the beginning. Repeat steps 2 and 3 until all surfaces are read. During this repeating process, the details of an object are added up until it is completed shape is obtained. So let's see. So adjacent areas that are not in the same plane must be separated by lines. So this is the guidance number 1. So for example, we have two planes, right? One plane up here and another plane down here. They are not the same plane. So it has to be divided by a visible line. It has to be divided by a visible line. So this is what they're telling us. One plane and the second plane. It has to have a visible line. But if they are on the same plane, then that line would not exist. Okay, so this is the top view that we have. All surfaces A, B, and C are not in the same plane, so we have, because of this visible line, we know that they are not in the same plane. Some of the possible objects' shape can be like this. This is a flat plane, flat plane, flat plane. It can also be a circular or like a fillet over here, and you would still see it looking like this from the top. It can be also slanted, and you would still see it looking flat from the top. So these are possible shapes, and another one would be flat, flat, and this one is slanted. So these are all possible. So we need to look at other views to tell us which one is the correct one, right? Okay, so areas that show similar shape in more than one view is the same surface. Areas that show the similar shape in more than one view is the same surface. For example, let's see. So this is a similar shape. Therefore, they conclude that this is the same surface. Is that correct? I don't know. Let's see. So this is my front view. This is my top view. This is what I'm looking at. It has a similar shape. But if I'm looking at from the right side, which is from here, I also see the same thing. So we are going to assume that they are the same surface, which means that this guy over here, the guy in green, is slanted. Let's assume that. Let's see. And if we look at the front view, it is looking like it is slanted, right? So this is you trying to draw the object, and it looks like that. And this is a different plane. If we're looking at from the top view, we would see that maybe it's over here because we have a hidden line. I'm going to assume that the plane for the red guy over here is here, because we also have, from the right side view, we also have this gap. So I'm going to assume that the red side is here. Let's see. And it is correct. And then what about these two guys over here? They correspond to this side over here, which means that they make up the top of these guys, right? And you connect all these with the front view, and you would get your 3D object. Now we have not covered the different types of 3D object. We're going to do that later. But it is important for you to understand what your views mean. Okay, another example. So we have three views here. This guy is using the meter line to connect all the lines. So we know that this is going to extend over here and come back over here, extend over here, come back over here, extend over here, come back over here, and it just helps us to draw it later on. Okay, so these two guys have similar shape. Remember what I said earlier on? If two views have similar shape, we are going to assume that they are the same surface. If they are the same surface, typically it is slanted. So from the top view, you would see that you have some slanting over here. So let's see how that corresponds. Okay, this is a hard one, I would say. You have that slant over here, and you also have these two guys as your same surface. So that is like two angles over there, right? Okay, moving on. So this one is from your front view, and this is from your top view, it has a similar shape, we are going to assume that it is also slanted. So let's see. So if you try to extend these lines, right, this line only comes up to here. So the red part only is only over here. So this is why they drew it over here. And for this guy, let's see where it extends. It extends down here and down here. And for this guy, it is over here. Okay, so we are going to assume that the surface is over here, down here, next to the red and next to the green. And is it the same shape? It looks like it is the same shape. Oh, actually no. The same shape is this guy. This guy is not the same shape. So it's just a flat plane, I'm assuming. Yes, it's a flat plane. So this one and this one, it looks like it's the same shape, but it does not correspond to the lines. So this guy corresponds to over here. Okay, so the orangey looking surface over here is just over here. Okay, so this is why your extension lines are very, very important. Use it to guide your eyes. And then just connect these two, one surface, and this is the second surface that we see from the front side. Okay, and this would be the green. Next example. So we have these two views. Let's see which view is the same or has a similar shape. So this green has a similar shape with this guy. So we are going to assume it's the same surface, possibly slanted. If we look from the front, if we look at the top view, we see something that is looking like it's slanted. So let's see the extension line. Does it correspond to that? It does. Okay, so if we were to draw it, it would look like that. Even though you see it from the front like it's normal, but because of this line and it extends to this line, it has some angle. And you already know that it is supposed to be slanted because this surface and this surface is the same. So that was your hint. Okay. So what about this guy over here? We have a hidden line here, which means that we have something that we don't see at the back. But from the front view, we can see that, oh, there is different planes. 1, 2, 3. There are 3 planes that are not adjacent to each other. I would say the hidden lines is corresponding to this side over here. Let's see. And the top over here extends over here. The top over here extends over here. Let's see the extension line. Does it correspond to that? Okay, they are just drawing that first. And this side would be the flat plane over here. And this side would be over here. Okay, so I think the purple part and the green part, the guidance really helped you. I mean, like the hints that we talked about earlier on. But knowing that we have a flat plane over here, without actually seeing it at the front and the side view is quite, I feel like it is the tricky part for this diagram or for this drawing. So please take note of all the visible lines that you have, try to map them out, and try not to make a mistake, okay? So again, because we have these visible lines, we know that they are not adjacent planes, they are different planes. So that makes sense. Okay, missing view problems. First example, so we have these two views and we want to draw the right side view. So this was a previous example, right? And we saw that this was our right side view, which was a wedge or a triangle block. But if we are just given these two views, we wouldn't know that it is a triangle block. So how would you fit in this missing view? So unless you have like schema jawapan, you wouldn't know that this is the answer because there are a lot of possible answers. So let's see what are the possible answers. This is possible. This is also possible. Let's see again. The first one is this. It can be an L shape. If you have something looking like this, it has a similar shape, which means that they are the same surface, or probably not. So a possible shape is like that, L shape. Slant is also possible because remember we had like a guidance before. If they are the same surface, it may be slanted. That is also possible. But it is not possible for them to be a flat plane because they are divided by a visible line. So it has to have like some edge, right? So another way is, this is also possible, slanted. A circular arc is also possible. Have a circular arc over here. So we're gonna select this line and see what happens. So if you were to give me an L-shaped line or a circular line, or what else did we talk about just now? A slanted line, it doesn't matter because it is a possible view and it is correct. Okay? So when you have a missing view problem, I would get different answers from you. So you can't copy each other because it just means that you can't have the same answer because it means you're copying each other, right? So I'm expecting a variation of answers when we do missing view problems. Okay. So we are talking about this blue side over here. It is possible that it is slanted. It is possible that it can be a circular arc. It is possible to be an L or like a flat plane. Previously, they said the flat plane is not possible. Actually, it is possible, but they are just assuming that this side over here is ke bawah. Itu je. Actually, it is possible for you to have the line over here as well. Okay, so we're going to select this line for our missing view problem. Okay. To this side, we're going to select this line for our right side view to reflect this surface. Just now when we talked about this side over here, we're just talking about this line. Okay. So let's take a look at what we have so far. So this is a flat line which corresponds to this. This is a slanted line which corresponds to this surface. And we have an edge over here. They are of different planes. And this is another surface. It can be slanted, it can be an arc. So we're choosing an arc for this. Okay, so for the top, this is the top view. They want to construct this back. So it's just, we are assuming that it just goes down without anything fancy. And it's just a flat side on the floor. So just connect that two together. And for this guy, it is possible that it is a rectangular block. It is also possible that it is not the same orientation. It is also possible for another orientation of this rectangular block. And it is also possible for it to be a square block. And also a rectangular block. It can also be a cylinder, but we don't have a center line, so I'm not going to say it's possible. I wouldn't say it's a cylinder. We can say it's a half cylinder, yes. Yes, that's possible. So we're going to select the square. So as you can see, it is completely different from what we had earlier. And this is the beauty of missing view problems, because you can get a lot of correct answers. There's a lot of correct answers out there. Okay, another example. So you have these two views. Now let's try to sketch the extension lines. We're trying to figure out what this is. So I'm going to assume that it is a slanted surface. This is a slanted surface, this is a slanted surface. Judging from here, so let's see. There's no similar shapes over here, so this one is not a slant. It's not slanted. I'm assuming this one is a flat plane. And you have these visible lines because you have different planes over here. Okay, that makes sense. So from the right side view, you would see like an L, which is correct. You would see like an L because this side is flat. You would see the slanted side over here. What else would you see? You would see this. This is the same edge and another edge. So one edge, two edges, or two planes, 1 and 2. So 1 and 2. Okay. Looks about right. Alright, moving on to the next example. So we have the top view and also the right side view. Okay, this looks a little bit hard, but let's see how it looks like. So we have two holes over here. We have our center line. And then we have something looking quite weird over here. And from the right side view, this is what I see. So we are going to assume that this is this side. So from the front, I'm supposed to see something extending with a visible line, and I won't see this hole because it is a hole, so I'm not going to see it from the front view. So let's see. So we have this red surface highlighted over here because they are different planes. So they are kind of dropped, kan? So sebelah ni akan ada surface. From the right side view, you would see the purple flat, and then you would see some surface area over here and another flat. So this is the purple, the surface when you have to like have some height to go to the next plane, and this is the green plane. The green plane extends up to this point because memang extend sampai up to that point lah. Okay, so I hope this makes sense. So this is what you're seeing. This is the red surface. So how do we draw this for the front view? Actually, you just see a rectangular block even though it's circular. Like that. And they are of the same surface, which means that this is going to be all the way over here. They are the same surface. Okay? The blue line, there's no drop or edges, which means that it is the same surface. So now we have to take into account the holes that we can't see over here. So we are expecting hidden lines and also a center line because it is a hole. If you don't have that center line, you know it's not a complete circle. What else are we missing? Are we missing this guy over here? Yes, so let's do it. So here, this is the part where that corresponds to this guy. But we have it looking like a circular arc on the sides. What do we actually see from the front? We don't see this circular side. We only see it as a block, as a rectangular block. We don't see the circular side. So this is your missing view. Front view for this object. Okay, self-practice time. So given the top view of an object, sketch the possible front views. So let's do this together. So this is a possible view. If you are given this top view, can be a possible question. I'm giving you this top view, sketch the possible front views. So you extend your line, draw. In this case, we have an L-shaped block because we have this edge over here. What else? We can also have it slanted. Let's see. One side is flat, one side is slanted. We can also have both slanted. Like that. Or the other way around, like this. One side slanted, the other side slanted. That's also a possible view. So you actually have 4. You have more than 4. You can also have it as a circular arc, looking circular. You would still get this top view, right? Okay, so those are the possible answers. Okay, so you are given this top view of an object, sketch the possible front views. And we can see that we have one circle and a second circle, and we have our center line. So we can say that it can be a hole. It can be a hole, or it can be 2 cylinders on top of each other stacked, or it can be, let's see what's the answer. Okay, so this one is a hole. Another one can be a cylinder stacked. Another one would be, this one is not very common. You have something looking like this, which is actually common in our drawing in a lab, if you noticed. So this is our possible answers. Is there another possible answer for this? I can't think of any right now. I think this is okay. That's all. Thank you very much. So I'm gonna see you in the next lecture. Take care, guys. Bye-bye.